Welcome to today's program entitled Controlling Yellow Jackets and Wasps on School Grounds. This webinar is produced by the U.S. Environmental Protection Agency's Center for Integrated Pest Management. The views expressed by our presenters are for educational purposes only and do not represent the official views or positions of the EPA or the presenters' organizations. This webinar is part of a series providing information on the importance of integrated pest management, or IPM, to student health and information needed to establish and grow an effective IPM program. Yellow jackets and wasps present risks for students, faculty, and staff that range from painful stings to potentially severe allergic reactions. Today's webinar will reveal what draws yellow jackets and wasps to your school and the best ways to eliminate them. You'll learn to identify these pests and the steps you can take to manage them as part of an integrated pest management program. Protecting the health of children is a priority for the Environmental Protection Agency. Children face increased risk to their health when they're unnecessarily exposed to pests and pesticides. For this reason, the EPA recommends that all schools implement programs that promote the safe use of pesticides and integrated pest management. By developing a coordinated IPM program, school leaders demonstrate their commitment to promoting a healthy environment where students are more productive. Effective pesticide safety and IPM programs address not only the safety concerns of using pesticides, but also the causes of why pests such as yellow jackets and wasps may enter our schools. I would like to take this opportunity to introduce our presenters. Jody Gangloff-Kaufman is the Community IPM Coordinator and a Senior Extension Associate with the New York State IPM Program at Cornell University. Mark Harden is an IPM Specialist with the Howard County Public School System in Maryland. And Lynn Braband is Senior Extension Associate with the New York State Community IPM Program at Cornell University. First up will be Jody Gangloff-Kaufman, who will be providing us with background on yellow jackets and other wasps.
I'm Jody from Cornell's IPM program, and I'm going to talk about yellow jackets and other wasps on school grounds. We're talking about this because stinging insects are a risk for children. We know that yellow jackets and other wasps and bees thrive in the built environment. They thrive at the interface between their natural habitat and the man-made habitat because we provide a lot of surfaces and a lot of resources that they can access and they like to use. Some of the species of yellow jackets are cavity nesters in human structures, and we provide lots of cavities for them to nest in. They are also, many of them, scavengers. The worst pests are scavengers, and we offer garbage and concession stands and lunches and food, so they tend to be drawn to human activity. Yellow jacket colonies can grow to the thousands of wasps per nest, especially in the south and the west of the United States, where you can even have perennial colonies. And these can be extremely aggressive. And even in the north, collected as many as 2,500 foraging yellow jackets from a German yellow jacket colony in a school building. So we can have thousands up here too in New York. Yellow jackets and some other wasps and most bees can sting repeatedly. That's a problem because one yellow jacket can sting once and many can sting many times. The only one that can't is a honeybee. Stinging insects and kids do not mix. There are a couple of reasons, and one of them is that 4 to 8 kids out of 1,000 may have life-threatening allergic reactions to insect venom. And that may not seem like a lot, but in a school district of 1,000 children, which is common in suburbia or in the urban areas, 4 to 8 kids potentially having this kind of life-threatening allergy is a reason to pay attention to stinging insects on campus. These allergic reactions are increasing, as are many other types of allergies in the world. This, I think, is important. Many children have never been stung before. Kindergartners go off to school. They may never have been stung. So we don't actually know whether they can be or will be severely allergic. And I think that's also something to take into consideration. So yellow jackets and other species of major concern include the yellow jackets, the bald-faced hornets, which are actually a species of yellow jacket. We have paper wasps, closely related to yellow jackets. There are other species like cicada killers and mud daubers, And then we have bumblebee and honeybee nests, which are not really a risk in the landscape as they're foraging. You don't want to step on them or grab them. But at the nest, they can be dangerous. So I include those as a side issue. Really, we're going to talk about yellow jackets. This and the next few slides are some of the major species, definitely not all of them in the United States and Canada, but the ones that we come across that are pests. This is the eastern yellow jacket. You can see from the map. Now keep in mind, these maps are 35 years old, and these range expansions that you might see are probably much larger today. But here's the eastern yellow jacket, and you can see the pattern on the abdomen. It has a specific anchor shape at the top and open circles down the abdomen. The eastern is one of the most common pests in the east half of the United States, but it's also expanded its range into the Midwest and probably farther than that. The common yellow jacket is not that common, but you can see how much of a northern species it is, and range extends from Southern California to Alaska to Nova Scotia to the Appalachians. It's not that commonly encountered, but it has this wide geographic range, and it is a scavenger pest. I'll talk about it more. The southern yellow jacket is quite possibly the most annoying in the southeastern United States. Again, its range is probably larger than this. Long Island looks like it's at the northernmost range, but I've found these in my backyard, actually. I had a queen in my kitchen. So they are sort of expanding their range, I would say, northward. And interestingly enough, the southern yellow jacket is a opportunistic parasite of the eastern yellow jacket. So the queen will move in and take over an eastern yellow jacket nest. So they coexist. The western yellow jacket is the greater pest out in California and the West and the Rockies. And this looks quite a bit like the German yellow jacket based on that abdomen pattern. You can see the range has extended into the upper Midwest, and that's possibly even larger today. Here's the prairie yellow jacket. It does exist in the prairie states and California, the western states. Probably a little bit in the mountains, not so much in the desert. And then the German yellow jacket. This one I think is important because it was introduced or recorded in 1975 in New York. And so its original range is quite limited to the Northeast. But today, we know it's in California, Oregon, Washington, and probably it could be all the way across the United States in places. This is an aggressive, very well adapted to the human environment yellow jacket. They're scavengers. They are causing some ecological damage in New Zealand. So it's really the one of concern. It's an invasive species. So the nesting habits of the previous 6 or so yellow jackets that I mentioned, in general, these species make subterranean nests. They really do prefer rodent burrows and cavities under stumps and under logs and compost piles. They tend to be around ground level. Occasionally, they're found in structural voids. The German yellow jacket is notorious for making nests inside structures. And all of these make the layered cellulose comb, which is chewed up wood pulp, in layers enclosed in an envelope. And you can see on the left, there's a queen yellow jacket starting her little tiny nest with one comb and a single envelope. And over time, the workers will expand it and make it larger. So even though these are cavity nesters underground and in voids, they still create that paper envelope around their nest. Now on to other yellow jacket species. The aerial yellow jacket here, you can see this range goes from Alaska all the way to Southern California, all the way to the Appalachians. It's really quite wide. It sort of demonstrates how flexible yellow jackets can be in their habits. They can exist in very cold climates and very warm climates. This one makes a nest that is like its cousin, the bald-faced hornet. They both make a football-shaped nest filled with comb that is generally on the outside, not inside cavities. The bald-faced hornet pictured here is not the only black and white yellow jacket we have. It is a yellow jacket, not a true hornet. But it's one of several black and white yellow jackets. Although it is the most successful, it has the widest range of any of the species we're talking about today, and they're very common. I'll talk about their nesting habits in a bit. But notice that these two species have been photographed on flowers. They are definitely species that will visit flowers in the landscape, not necessarily pollinating, but definitely present in the landscape where you might not expect them. The European hornet is interesting. It was introduced to New York once again around 1850, and it has expanded its range possibly beyond this Midwest and South range. I'm pretty sure it's in the South. But it is really something you don't see in urban areas. You do see it in rural areas because the nesting habits are to be in old buildings, old barns, and hollow trees. It looks a lot like the giant Asian hornet, and people often report it to Extension that we've got giant Asian hornets finally, but we don't. It's just this large true hornet. Now, paper wasps are related to yellow jackets. They also make the paper comb, but they don't make a comb that's enclosed, and I'll show you pictures of that in a minute. This on the left, the black and yellow paper wasp, is the European paper wasp, Palistes dominula. And on the right is an example of one of the many native species we have. These are not particularly aggressive when they're out foraging, but when they are close to the nest, when they're guarding their nest, they can be aggressive, and they will fly at you and hit you in the face before they sting you. It's been my experience. The range of Palistes dominula, it was introduced in the early 80s to the Northeast once again, and it has expanded all the way across the United States into Canada, and reportedly, some feel that this species as a predator has lowered the number of surviving silk moth larvae because they do prey on big larvae like those silk moths. And it may be expanding and pushing other native species out of the way. So the different nest styles, to go back to this picture, this is the vespula, which is the yellow jackets. They make a tiered gray paper comb. It's wrapped in an envelope. It's built inside of a cavity. The larger cells are queen cells. The smaller cells are worker cells. The Dolicha vespula, this is the aerial yellow jacket and the bald-faced hornet, make tiered gray paper combs, but they are wrapped in an envelope and built on the outside of structures or up in trees. I often find bald-faced hornet nests hanging from tall trees in my neighborhood and everywhere you go along parkways and things. They're generally out of the way. They're not usually in places of great human activity except for cars driving, but they can be found on the sides of buildings, on the tops of school buildings, on the HVAC material, and can get in the way. They like doorways too. Now, paper wasps construct a single tier open paper comb, no envelope, but it's built under shelters. So where you have eaves, where you have loose flashing, especially on a school building, or inside an attic, any kind of a little void that has close proximity to the outside, they can build their nests under decks, in playhouses, and in fence pipes. This is a common thing for athletic fields. When the fence pipes are open, you often find Palistes dominula, or a European paper wasp nest inside that fence pipe. They love anything metal. I think it's because it's super warm, so it's good to make sure you're inspecting fence pipes on the athletic fields to make sure there aren't nests inside those. The European hornet makes a tan paper comb. This is what sets it apart from the bald-faced hornet. The tan paper comb inside an envelope, but it's generally in an old barn, a hollow tree, and not near human activity. So don't worry too much about them. Here are some features of minor concern to schools. We have mud daubers and potter wasps and spider wasps, and I just used one picture of a mud dauber here. They're not really that much concern. Even though they make nests on the side of buildings, they're not likely to sting because they're solitary. They are out there foraging and making nests and not guarding large caches of larvae or resources. For other reasons, they destroy wood, but we're not talking about them today. Generally, as they fly around, they're not harmful to kids or staff. And the same is true of cicada killers. They are common on school grounds, particularly baseball fields or fields with poor grass. And although they fly around the way carpenter bees do, guarding territory, they're not dangerous to humans. Some biological differences among these, for the yellow jackets in particular, include whether or not they're scavengers or predators. The scavengers are the ones we have to worry about because they're the ones coming into contact with kids, with food, with concession stands, and with dumpsters. So the southern yellow jacket, the German, the eastern, and the western, they're all primarily scavengers. They're also predators, but their primary goal is to scavenge in the environment, so that brings them into contact with people. Vespa crabro, that European hornet, is primarily a predator. So it means we don't see it too often in places like dumpsters and concession stands on school grounds. Now, the bald-faced hornet and the aerial yellow jacket, they sort of waver in between. They'll forage in natural places, and they'll pick off other bees and flies and things, but they'll also visit a picnic or, a soda can. Bald-faced hornets, as I said earlier, tend to nest high in the landscape. They'll be in trees, at the peak of a building's eaves, places like that, and they're generally out of the way. If they're foraging in a place in the landscape, cherry trees or a fig tree or something like that, they can become problematic. We need to know where that nest is. The aerial yellow jacket nests either low or high in the landscape and tends to be on the side of buildings or in lower bushes. I've seen them in playground equipment and things like that. So it's good to know where they are so we can deal with the nest. Yellow jackets and bumblebees tend to nest low in the landscape, under compost and stumps, underneath trees, and especially where there are rats and rodent burrows. Now, paper wasps have these open comb nests. They're both high and low in the landscape. They can be anywhere, and they tend to be at the roof level of buildings or in the window frame. Now, only queens overwinter in all of these species except honeybees, and except in the south where sometimes we get perennial nests. Honeybees overwinter as a whole colony and start again in the spring with a lot of workers, but the rest do not. So honeybees, you might find something like this, low in a tree or in a shrub. If it's way up high, don't bother with it because they'll move on in 1 to 2 days. But if you find this in a low tree or shrub, it's worth calling a beekeeper because this is worth something to a beekeeper. If you find honeybees in a wall void, if they're coming and going from a wall void, you're going to need to take drastic measures to get rid of the honey and the comb that is already in there, or else you will have secondary pests. And nest disturbance is an issue for ground nesting yellow jackets and near feral honeybee nests. Vibration and motion can be alarming and set them off to a defensive reaction. So what happens frequently with farmers and grounds maintenance folks is that mowing over a ground nest entrance that you formerly didn't see is a common way to get stung quite a bit, and I'm sure everyone here knows that. So it's good to know where those nests are. Bumblebees can be very aggressive at the nest, and they will nest just in tufts of grass, in an unmowed field, or underneath, something in the landscape, a piece of wood or things like that. Kids, I know me growing up, we were throwing rocks at bald-faced hornet nests, and you get too close to that, you're sure to be stung. So, the bottom line is to cordon off these active nests if they're discovered. Make sure nobody goes close to them until they can be treated, or if you can keep them cordoned off for the whole season, you may not need to treat them. Yellow jackets have seasonal behavior where there aren't perennial nests in the north and most of the country anyway. Nests remain basically unnoticed at this time of year because the queens are still flying. I was upstate last week, and the queens were flying everywhere, just German yellow jacket queens. So they're still getting space together for creating nests. They haven't laid eggs yet. But by the time midsummer comes, the colonies are getting larger. That's when you start to notice them. By the end of the summer, the new queens are produced, and they're leaving the nest, and the rest of the colony starts to die off. The old queen eventually dies, and the workers, which will hang on as long as they can and feed on sugars, they'll forage on flowers, they'll forage on soda, they depend on the communication from the queen via pheromones. They become sort of aggressive and confused, and that's when people are likely to be stung. There's some important health information that I'll share. Most people will experience pain and swelling and itching and redness for as long as a week. Itching can last longer than that after being stung by a wasp or bee. I honestly don't think there's anyone who doesn't react at all. But a rare case might be a life-threatening reaction, and that's anaphylaxis, when someone is so severely allergic to the venom from a yellow jacket sting that they go into shock. Schools today have policies for the administration of EpiPens for food allergies. Keep in mind, EpiPens are also for these severe reactions to insect stings, and consider putting that into school policy to include venomous insect stings in that policy if it's not there today. To avoid stings, some recommendations here. Advise students and staff to stay calm if there's a wasp or a bee flying at them. Don't swat at the insect because it can be construed as an act of aggression. Use slow and gentle movements to move away from the insect that might be bothering you. And it's always been something I've done is to move into the shade. It seems to work. It's anecdotal. But if I'm in the shade, I feel like I'm not as visible to the stinging insect that's flying around me. So if that doesn't work, move indoors until the threat goes away. And avoid crushing a yellow jacket or a honeybee. In particular, yellow jackets have alarm pheromones in their heads. So if they are crushed or eaten or something like that, the alarm pheromone will bring along their conspecifics, their nest mates, and tag you for more aggression. Check your drink before taking a sip, or use a straw in a can of soda. That's a good recommendation for schools or for sporting events, because yellow jackets will crawl into that opening. Avoid sweet-smelling perfumes during the season. Bees are definitely attracted to sweet smells. I'm not sure yellow jackets are so much, but some of the pollinators do rely on sweet-smelling scents. And this probably is more important. If you wear dark colors while you're mowing, or if you wear dark colors near a nest, you might attract their attention because you sort of look like a bear. And bears are predatory on the social stinging insects, bees and yellow jackets. So avoid wearing dark colors.
Thanks for that outstanding information. Next, we're going to turn it over to Marty.
So I'm going to talk a little bit about integrated pest management for yellow jackets and other wasps. First, let's talk about IPM, though. When you're going to do IPM for yellow jackets and wasps, Jody just did a really good job talking about different species. You really do need to know what species you're dealing with, because you're going to have different risks and you're going to have different locations that they may be. Next, you're going to have to figure out what you're going to do. And what you may do is seal up or seal out those stinging insects from your building. In other words, seal the nest once it's dead and seal them so they can't re-nest on your building or wherever they're nesting. Your staff and students about the risk and what we're going to do, what kind of treatment we're going to do to remedy the situation. I understand that Lynn's going to talk a little bit more about trapping, but we use jar traps and light traps as an adjunct once we remove a nest, just to pick up stragglers. And then you might treat with pesticides, and then a little later I'll discuss this a little further, but we often use dust if we get to that point where we decide we have to use pesticides on a yellow jacket nest. Lastly, you want to determine management practices which may impact abundance. So I'm talking about things like changing the way you deal with your trash or other items in your school programs. So Jody did a good job talking about this, but I had my own set. How do you get stung? Sort of the opposite of what she was talking about, maybe. But if you swat at them, I teach kids about entomology all year long. Well, I teach them: wasp lands on you and you're not on a nest, sit still. Just wait. They'll fly off. They're there, just checking it out, and we're not food for them, so they're going to leave. If you are standing on your nest, you're definitely going to get stung, and you want to move away as quickly as possible. If you have sweet things on your hands or your body, a lot of our kids are going outside after eating. Some schools, we've had a policy where they have to use hand sanitizer to remove ice cream or other sweets from their hands to reduce the number of stinging insects on the playground. Yellow has been shown as a color that attracts pollinators. So if you're out in the middle of a playground and you're wearing bright yellow and there's no other plants around, they might be coming to check you out because of the color yellow that you're wearing. And then another thing you can do to get stung is don't move away when somebody else disturbs a nest. The worst case we've ever had was a young student stepped on a nest in a bed, and the whole group of students didn't do what they were supposed to. They waited to get inside, and a lot of people got stung. So if somebody does hit a nest, you want to get everybody to move away as quickly as possible. One thing we do in IPM for landscapes is we tend to not use herbicides on our lawns. Well, that leads to a lot more clover and other plants on school grounds, and that will increase the stinging insects present there as well. So it's a balance. We're going to draw them in, but while they're foraging, they're not as aggressive as if they have a nest. However, you may have some other nesting going on just because there's food available. So here are the life stages of a native paper wasp species. And the point of this is that you can't just remove the adults. You need to remove the nests and crush that nest, because when they've created the nest, they have larvae on the right here inside each one of those cells on their nest. And if you don't remove the nest, you're going to have more back later on, and they're going to continue to forage, and they're going to continue to be a threat. So you need to get rid of the adults, get rid of the nest, and actually crush the nest or dispose of it in a way that they can't emerge from that later on. Yellow jackets, as Jody has talked about, have paper around the outside of their nest. But what you may actually see is what's in the bottom left. You may have a yellow jacket or a number of yellow jackets coming out of a hole in the ground, and you may not know what's below it. So I teach our staff not to mess around with those, because you don't know if you have 20 or if you have 1,000 later in the season, and we shouldn't be putting people at risk with dealing with that. It should be professionals dealing with that. But yellow jackets are something we have nesting outside on our properties, and we definitely have them nesting in cavities in our buildings. So for nesting locations, and again, Jody brought up many of the places, but I'm going to show you some actual photos of nesting sites. Here we have the end of one of our types of fencing, and you can see there's a Diminula nest in the end of it. Any kind of hole where it's big enough for them to get in and out, you're going to have Diminula or other species nesting in it. Things like hollow lettering on schools, or the ends of any kind of railing or support rods that are hollow. On plastic equipment, where the arrows are, the places we see them on this type of equipment are where the screws go into the equipment, or in the gaps where they can get into the hollow part of the equipment. Now, we have an issue where we have a warranty on this material, and we're not allowed to actually use caulk or other materials to seal up the holes. We have to use things like copper wool or steel wool that can be removed, because otherwise we void the warranty. So we have a little bit of a struggle with that issue when we try to eliminate paper wasps from this type of equipment. For our portable classrooms, there are a plethora of holes everywhere. Starting from the far left, you have where your equipment attaches to the building if it's not sealed up all the way. You have the corners where you have a drip line for the skirting. You have underneath the wooden walkway where it's hollow, and every single pipe on the handles or on the bottom of the handles is a place for nesting, as well as under the ramp itself. Wooden railings provide sort of an eave on the handles, so the real risk with that is you may have a very small nest and not see it, and a student or a staff person puts their hand on there and they put their thumb right on the wasp and they get stung. So you have to inspect that and remove nests when you find it. And again, the holes on the ends of any kind of railing are going to be filled up with, especially Diminula in Maryland here, but other species as well. Hollow objects, like I said, you can have hollow lettering, and each one of those letters may have a paper wasp nest behind it. And you get nests that look like the thing that they were produced inside of. On the right, we have a school bell, and you can see the nest on the left there was formed just to fit inside that bell. They aren't that aggressive, though. I mean, even with that bell going off and it was not working properly, those paper wasps weren't attacking everybody every day. They tend to be a lot less aggressive than the yellow jackets. Again, siding with a gap in it in the upper picture or in the bottom two pictures, any kind of pipe chase. This kind of a hole, as you see in the bottom right, opens up into the wall void. So that's a perfect place where we get a lot of yellow jackets nesting. They get inside, they can create a nest of any size within there. You may not know how big it is until you stand for a little bit and watch it. The eaves are a common nesting place as well. Up underneath the rain gutters or any kind of eave, you'll get a lot of paper wasp nesting. We have louvers, hardware cloth on the inside is enough to let them come inside, so the nesting may be underneath the louvers or in your building. In this case, you need a tighter screen to keep them out. The risk of getting stung for paper wasps is just not as great as for hornets, and part of the reason is the nest size is much smaller and they're not as aggressive. This nest is about as large as I've ever seen of a paper wasp, and you might have 35, maybe 40 adults on it late in the season. And you can still walk up to this nest of Diminula and pull it off of the wall, and at the time you pull it off, they won't attack you. And I can't really explain why that is, but they're just not as aggressive in defending their nests. The end of piping, especially late in the season, you may see the entire colony of Diminula outside. And I think it's because of heat. As it gets much hotter, they tend to get too hot and they'll air themselves out on the outside. And also, these are queens that are going to overwinter, so they may be getting ready to leave the nest. Natural locations for larger nests that are on the edges of our properties, a lot of times we don't have to remove them. I'm not sure if that's something that we need to control, and you have to make a judgment on that. I'm going to tell you a little story about a situation. We got a call that there was a huge yellow jacket nest by the bus stop. All of a sudden in the fall, not been reported before. We get there, we find lots of yellow jackets on the ground, and we cordon that area off. When you look up on the pine tree, you find that there's yellow jackets foraging on the needles. And if you look a little closer, you see that there's a pine aphid on the branches, and they're creating a lot of honeydew. And what the yellow jackets were doing is they were foraging on the honeydew on the ground, and they were foraging on the honeydew on the tree. And you could walk among them, and they would not be aggressive because it wasn't a nest. But if you were to get one trapped under your foot or something, you would definitely get stung. So we were getting ready to actually control the aphids since we didn't really have a yellow jacket nest. And what happened was we had a thunderstorm, and that thunderstorm actually washed all the aphids off, and we ended up not having to do a control. So sometimes it's not a nest that's being reported. You really have to do a little investigating. Again, yellow jackets where they nest can be anywhere, but late in the season you can't miss their nest. They're very large and they're very aggressive. What do we do for sealing up the holes once we either control a nest or we have a nest in a building? We use expandable foam, like on the left, or we use copper wool. This is Stuff It, which is a pest control material, or you can use stainless steel wool, which won't rust, and that's the key. Or you can use the wool behind the expanding foam. When you put the foam into holes, like in this pipe, it'll expand through the whole pipe and you'll get it popping out, but you can remove it afterwards. And that effectively eliminates that nesting site ahead of time for any of these species. Fence posts, signposts are a real problem. The middle picture shows a signpost installed the correct way with the flat side towards the sign. Now that's not how most people like to install them because you get rust. But if you don't, you create a gap like on the lower left where these species love to nest. And what you can do is you can fill it with foam, again like on the right, and even if there's a nest in there, you will cover them up and eliminate that problem. When that foam gets old, it does get sort of brittle, and eventually you'll have to replace it, but it works for a number of years. Another place we have problems is our weep fence along the access to the building. Those weep fence are access to the interior of the wall, but you can't just fill them up because they do have a purpose of letting moisture out. So there are a couple building materials which effectively eliminate that for stinging insect nesting. The bottom are plastic hydrovent material. That really has to be installed when you build the building. However, mortar net weep vents, which come in a multitude of colors up in the upper side here, those are able to be put in retroactively, and they work very well. So on the left, you see a hydrovent piece that has been installed when the building was built. And on the right, you see some mortar net, which was installed later on. And it can be retrofitted to any size hole. So it's very effective. And it still allows that weep vent to function. When it comes to dumpsters, the first thing you may think of is repair. We need to make sure your tops are covered up so that they're not able to access food through breaks in your dumpsters. This is a picture of yellow jackets coming and going from a dumpster that has been dumped. It's been cleaned, but the door is open, and you can see highlighted some little yellow jackets, and there's a fairly large one sort of mid-screen on the left there. They're coming and going from this dumpster, and yet the dumpster was cleaned up. Trash bag use will eliminate that. They have to tie the bags closed at all times, and they need to line them so that there's no trash. You can't have trash loose in the dumpster as in the bottom left. You need to empty the trash after last use in all the rooms so that, that we don't have that for interior pests, but for outside, we want to make sure that those dumpsters are kept clean. If you don't, and you dump your food in, this is what remains on the bottom of a dumpster after it's been dumped. And that's what those yellow jackets are foraging on. Their access to food is going to bring them to the school in the first place, and you'll have more nesting on the building just because there's food available. And the last resort for our IPM program is using chemicals, but it is a necessary option. And for stinging insects, especially for yellow jackets, and that's really primarily what we use chemicals for, we use dusts. And the reason I recommend that is that it not only eliminates what's in the nest at the time, it's there when the foragers that are out come back and they get treated as well. And it's there when the larvae emerge to treat them when they leave. So we'll treat a nest, we'll wait a few days to make sure that we're getting everything that's coming back and everything that might emerge in the near future, and then we'll seal up those holes so they can't be used anymore. Thank you all for your time.
Thank you, Mark. Lynn, please take it away.
Okay, I'll be talking about some ongoing applied work that we have been doing with yellow jackets, paper wasps, and other stinging insects here in New York State. Okay, the framework for this presentation and the work that we've been doing is seeking to prevent or at least reduce the risk for getting stung. This includes assessing or monitoring your buildings, your grounds, and then when needed, use the least risk effective control options. I would like to refer you to a book which Jody wrote a few years ago, which summarizes all the work we've been doing with stinging insects here in our program and other information too. It classifies the critters by their relative risk of getting stung by them, with the paper nest building or social wasps having the highest risk, the social bees having a moderate risk, and the solitary wasps and bees have the lowest risk of getting stung. And Jody has already gone over these, but just as a reminder, with the social wasps, the highest risk group, we're talking about yellow jackets, paper wasps, and also this interesting critter, the European hornet. And then the social bees, the honeybee, and several species of bumblebees. And most members of this group are actually, by far, that has the most species, are the solitary bees and wasps. And these include the carpenter bee, which again, in terms of stinging risk, is a low-risk species, but the concerns that we have is with the structural damage that might be associated with it. And many species of so-called ground bees from several families. And with the wasps, just a couple of examples, like the cicada killer and mud daubers. Okay, as Mark indicated, it's an excellent idea to regularly go around your structures and look for those gaps that wasps or other pests may utilize and close them proactively. Spring and fall in general are good times to do this. And also, while you're doing your inspections, just look for those attractants. So this is a school dumpster area, which definitely needs some work. The dumpsters on the left are possible food attractants, while the dumpsters on the right are cellulose for the paper nest building wasps, the social wasps. They build their nests out of paper, and they get that from harvesting cellulose. And so the cardboard here was scattered about the landscape, could be a potential attractant. So this is the type of work which we have been doing here in New York State. We've been working with vacuuming nests, proactive paper wasp management, yellow jacket nest removal management, yellow jacket trapping. Be talking a little bit about low-risk species, particularly carpenter bees, and a couple techniques that we tried but did not work out for us. Vacuum and exposed nest, and most of these would be paper wasps, but often like aerial yellow jackets and some of the other yellow jackets. So I know some school districts which fairly regularly do this. This is bee suit work if you're doing a late season nest that has a lot of workers that are defending that nest site. This is a wall void nest, which actually Jody found the entryway, and she did collect at least 2,500 yellow jackets. And although she didn't eliminate the nest, she felt that she definitely weakened it and then possibly reduced its longevity. In the spring, it's a good time to start inspecting those sites on the buildings where are particularly sensitive. So buildings that are near playgrounds, for example, the sides of buildings near playground, around major entry doors, and just those locations where when school reopens in the late summer, early fall, you really would not like to have those large late season multi-worker nests. You can also use the sky as a backdrop to scout the perimeter of the roof for wasp activity under that drip edge. Paper wasps often like to nest under there. Mark and Jody already talked about, particularly for the introduced paper wasps, Polypsis dominula, the wide variety of sites that they may nest in, and just show you a few more of places where we have found this species of paper wasp nesting. Now, when you do find early season nests, again, the paper wasp nests are the easiest to find because they are frequently pretty exposed. You're not dealing with a lot of workers. You're just dealing with the start of a queen or possibly with the dominula that she may be assisted by a sister or two. But you can physically remove that nest. It's a low-risk situation. You see, I'm not wearing a bee suit. I'm also wearing dark, so I might look like a bear. But again, there are workers guarding that nest site. It's just a queen or two, and you can physically knock that down with a stream of water, as I'm doing, or a long pole. One advantage of the water is if the queen is there, not only are you knocking the nest down, but you temporarily ground the queen frequently. You can just step on the queen. Okay, we found in doing this and working with schools on this that if paper wasp nest, again, looking on those sensitive areas on your building where you prefer not to have them, that once every 2 weeks, beginning in May, generally up here in New York, if it's a really, really warm spring, April through July, then that nest building is greatly diminished, and you avoid a lot of, again, those late season multi-generation worker nests. Another possibility besides just physically knocking them down is just a quick air assault in the early morning. Okay, yellow jacket nest entrance. Okay, there's several species of yellow jackets which we have a wide variety, that's already been discussed, of sites where they nest. And the most problematic are usually nests that are in wall voids, and they often aren't noticed until late in the season when you have a steady stream of workers going in and out. And usually the most practical thing that can be done is, as Mark indicated, an insecticidal dust. Be aware, though, that especially if you're using some of the dust like the plant essential oil dust, which don't have as quick as a knockdown, to as much as possible ascertain if there's any way that you might drive the wasp inside from the wall void. Also, once the activity has ceased at the nest, be sure to close that entry hole so that another queen may not use it. Vacuuming, as we already indicated, may buy you some time. For underground nest, again, usually a dust is the most practical, and again, the plant essential oil insecticides, the botanical insecticides, have greatly improved in terms of their efficacy and are definitely a tool which can be used. Digging up ground yellow jacket nests is much more labor intensive, and it's definitely bee suit work. Another option, if it's in a location on the grounds which you can fence off temporarily, it's not heavily used, and just keep people from using it until the season is over for the yellow jackets. That's also a possibility if it's a wall void nest and it's a location on the building like an isolated small courtyard or something like that is rarely used anyway, is just to cordon it off until late in the season and to close the entry hole. We have ongoing research with these food-baited container traps for yellow jackets. It's well known that these traps, which are a non-insecticidal approach, they have a sweet liquid which serves as both of the bait and the killing agent, as yellow jackets go into the container and they drown. And catch a lot of yellow jackets with these, but it's been debated on whether you're really reducing the risk of being stung or not. So we have been doing some experimental testing, trying to get some information whether these traps reduce the stinging risk. And our major assumption with this research is that the fewer the yellow jacket, the less the likelihood of getting stung. And our study design has consisted of paired plots of traps on poles. This is a graphic illustrating one pair of plots. The plots are not side by side as shown here, but usually 80 to 100 meters apart from each other. But these are 100 foot by 100 foot plots, and the red dots indicate trap locations. At the center of each plot, we have a triad of traps, and that's meant to mimic what we're seeking to protect, like a concession stand. Then every 20 feet around the perimeter, on one plot in each pair, we would have traps set on poles, and on its sister plot on the perimeter, we would not, at any particular trial, have any traps, only the center traps would be trapped. So to illustrate this, this is one plot where we are trapping the perimeter. We're looking down one side of the plot. And this is a companion plot. This particular trial, we are only trapping in the center of the plot, and the poles on the periphery on this trial, we do not have traps. We found quite consistently that when we did trap the perimeter of the plot, we had about 30% fewer yellow jackets caught in the center traps. So we didn't eliminate it, but we did quite consistently reduce it. But we also found something else quite interesting. So to increase the number of replicates, we had not only several pairs of plots scattered throughout the state, depending upon the year, but we also had to increase the number of replicates over time. So our trials were arbitrarily picked at about 2 weeks for length, and then at the end of one 2-week trial, we would switch the plot on each pair which had the perimeter traps. So for example, if trap A On one pair of plots, we were trapping the perimeter. On the next trial, we moved the perimeter traps to plot B. And what we found, usually pretty consistently, is that when we did that, our total captures of yellow jackets dropped off at the beginning of the trial and then gradually increased to the end of the trial. And then when we switched the location of most of the traps again, frequently our total captures would drop off again and gradually build up again. What I concluded is that we had a who moved the cheese situation. The traps were not merely just intercepting yellow jackets that would be flying by anyway, but that the traps were actually attracting yellow jackets. So that when we moved the location of most of the traps, it took a while for the yellow jackets to figure out, if you will, where the traps went. So to conclude our work to date, and this is ongoing work, recently we have gathered a lot of data on both the weather conditions throughout the whole study and also the landscapes surrounding each plot, and we're still analyzing that impact and that on some of the variability we've had in the captures. But currently we've concluded that our best use of these traps is if there already exists a strong attractant, like a concession stand at a football game or something like that. If you don't have some strong food attractant, such as many school playgrounds, you may actually, or at least potentially, be increasing the risk of getting stung by the use of the traps. The distance from the protected site to the traps may be important, probably is important. We've worked with some festivals on the use of the traps to reduce the stinging risk. And our conclusions in this applied work of these festivals is to start trapping 1 week before the festival and then trap through the festival. The traps, in this period, need to be regularly serviced, preferably daily. Other tips for trapping yellow jackets. Late in the season is when these foraging workers are at their peak and particularly seem to be attracted to the sweets. So use a sweet bait, and it doesn't have to be anything fancy or expensive. We use cheap fruit punch, watered down actually, to make our fruit punch go further. And Vaseline around the inside rim of the bait jars may help reduce escape. We've also been doing some work with a surfactant, i.e. soap in the water, to reduce escape of the yellow jackets out of the trap. The trap should be above ground level, and they're best located in sunny sites. And of course, they should be used in conjunction with other good IPM practices, such as sanitation, to reduce or eliminate alternative food sources, such as lids over soft drink containers, things like that. Switching to the lower risk group, the solitary bees and wasps, and we're talking about the carpenter bee, and again, they are, in terms of stinging risk, are a low risk situation, but where our main concern comes in terms of the potential structural damage. Jody and other members of our team have ongoing work with carpenter bees, and last year their research focused on carpenter bee traps, and there's a couple examples of these traps shown on the slide. Will they catch carpenter bees? And they found, yes, they do. They catch both male and female, but they are non-selective. They also catch other insects, and maybe some insects that you would prefer not to catch. Possibly this bycatch can be reduced by removing the traps once carpenter bee activity decreases. This year, they're looking at reducing carpenter bee activity and damage by both trapping and filling the holes. And they're just using common, readily available material for filling the holes. They are finding this spring that the carpenter bees, once the holes are filled, do not appear to attempt to remove the sealant, but the females apparently become aggressive with each other, and this may allow them to become easier to be trapped. Now, often a lot of the damage associated with the carpenter bees is not only with the burrowing of the bees themselves, but with the woodpeckers going after the bees and the bee larvae. That's kind of a tough nut to crack. There's a new product on the market, which I have to emphasize, I know of no independent university-based research on this product yet, but I'm on several chat groups of practitioners in pest control and nuisance wildlife control, and many of them are raving about this product. It's called optical gel. It's produced by the company Bird Barrier, and it comes in little plastic containers that attach to the side of the building, and it's a bird repellent billed by the manufacturer as a multi-sensory bird repellent. They claim that what they can see looks like fire. They also claim there's a scent they don't like, and if they land on it, it's sticky. Again, I know of no independent research yet on this product, but many participants are starting to rave over it. few comments about some other solitary wasps and bees. This shot was taken of cicada killers, one of a group of cicada killers that were nesting in the central courtyard of a college campus where I'm located, and the head groundskeeper did an excellent PR job. He was receiving complaints about these, and again, this is a college campus, so theoretically anyway, we're dealing with adults, not children. He put out a PR piece which explained the low risk of getting stung, described the biology of what's going on, and essentially said enjoy the show. And then we have many species of ground bees. We're finding how important these are as pollinators. This is one common species in about mid-spring in our area. This is my street. And they are, particularly as a cicada killer, is also attracted to light, often sandy, poorly vegetated areas. So this was a site in the front yard of a neighbor of mine which had some excavation done, and grass was not growing yet. And that spring it had quite a few ground bee burrows. That's my then 5-year-old granddaughter, who I talked into standing by it to get a photo for perspective. You can see by her look that she trusts Grandpa, but she's not certain about this. Again, if these ground bees are in a playground with a lot of little children running around, that may very well be a situation where control needs to be done. Since they prefer lightly vegetated areas, the long-term solution, if at all practical, hard in a playground of course, is to increase the vegetative cover, whether that means adding organic matter as part of the mix or whatever. A couple things which we tried but did not work out very well for us. There is the idea that if you have a ground yellow jacket nest, if you put a transparent glass container over the nest, they will not be able to figure it out, that they see the sky, they will keep trying to get out, and the nest will starve. This was tried a couple times down in Long Island by members of our team and some collaborators, and you can see the mason jar is over the nest hole, and the stick is where they came out. Either that was another site they came out of, or they dug a new site. When I mentioned this to a couple other presentations, one by a pest control guy who responded, and another by an entomologist, they felt that our mistake was that we did not use a round bowl. Another thing else which we tried in a more systematic fashion, in the Florida Keys, there is kind of a local culture where people paint the undersides of their porches sky blue, and they're thinking that will trick paper wasps to not build there because they think it's sky, it's not overhang. Well, we tried this actually for a utility in a couple of ways, is that we alternated some eaves with the sky blue paint versus sections of eaves that did not have the paint. And then we also, with plastic flower pots, painted some of them sky blue and others we didn't. And here's a couple of the arrangements which we tested. And our results were that possibly there was some reduction of paper wasp nest building in the sky blue sections, but not enough that we would recommend it as a technique. So that's all I have.
Thank you very much, Lynn, for that fascinating presentation. It leaves us all a lot to think about. I'd like to thank Jody Gangloff-Kaufman, Lynn Braband, and Mark Harden for their informative presentations on yellow jackets, wasps, and their control on school grounds.